Good afternoon. My name is Jiri Novotny. This is my colleague Ondrej Babec, and today we are diving into a topic that keeps your data as fresh as your morning coffee. We're of course talking about CDC, or Change Data Capture, and how Debezium and Debezium server utilizes the CDC. So what is CDC? We actually have two definitions, because one is a formal one that's quite dry. It's process of recognizing changes in source data systems and their delivery to downstream consumers so they can take actions based on these changes. Dry, but technical, right? Then we have the human definition. CDC allows you to subscribe to data changes in your database. So whether it's insert, delete, update, anything happens in your database, you capture it that it happened. Let's go for a quick review how it works. On the start of the pipeline, you have users that somehow work with the database. They insert some new data, they update something, they delete something, they drop some tables, whatever you want. The changes hit your database, they got written in transaction logs, we'll get to them later, no worries, and then the magic happens. In our case, Debezium somehow catches those changes, processes them, and sends these events to some event stream where the downstream consumer or anything you want works with these changes. And what's the magic? Ondrej, tell us, please.
Okay, so if you are trying to implement CDC by yourself or you are simply trying to work with that, there are basically two groups of CDC or two ways of to implement this. There is not really strict definition by that. But before, have you guys ever worked with CDC or do you have any idea how it's working or anything? Can you please raise your hand?
Hands up, guys.
Okay, not many. So we'll go through that. There are basically two ways how to implement it. The first one is Poll-Based CDC, which polling in this case means that you will regularly query the database with some period and you will add more and more information to that to recognize what changed and not. There is an example for that. I will show you what's the catch for that. The second way is to grab the transaction log, which Jiri will talk later. And there is also like poll-based / specific database mechanisms. There are, for example, with Oracle, they have some proprietary solutions for that, which you will have to then poll, and it's much more complicated. But let's go through the poll-based mechanism. I hope you like Die Hard, because I was watching Die Hard when I created this example. So you have very simple table, just 3 columns. The data type doesn't really matter, but you have first name, surname, and you have some identification. And now we want to do CDC on table like this. So without any more information, this will be really hard to recognize any change that can happen. For example, how would you recognize that name changed from the previous state? You have no idea of last changes. So you add timestamp. Logically, you will add some more information. So now, if something changed, it will just modify the timestamp. But there is a catch. What about the deletes? Because the information now misses. It's not here in the database. Hans went missing. You don't know when. You don't know how. You don't know anything about that. So that's the first catch with the poll-based CDC. If you are going to implement that by yourself, but there is still solution for that. Yeah, you will simply break all the normal forms of the database, and you will add another information, and you will stop deleting the rows. So you will add something like flag, for example, when you will say this was created, this was updated, and so on. So now everything is clear, bright future ahead of us, and now I can see the change. Actually, I know that there was an update. The second row was deleted at some point. We know the timestamp, everything. So that seems it's quite right, and there is no problem at all with that. That's still not quite right. How can you satisfy the needs that you don't miss any changes at all? Like you can see that there was John McClane 2 or whatever number was on the previous slide. Now it's 9. And do you know that there was not like 5, 6, 7? So at this point, we will start to think about how can I choose the period of polling, because it's quite problematic to select that. And with the bigger or let's at this case smaller polling interval, you will get more latency, you will need more hardware, and you will need everything. There is, I don't know if you guys are familiar with Nyquist-Shannon sampling theorem. It describes exactly the same thing. There is very simple, I say dumb description, which I like very much. It basically says that you need twice faster the polling than you are doing the updates. If you are changing the data each millisecond, you would need to be faster than the millisecond, which is not going to happen usually on these old data centers with Oracle rack instances and this kind of stuff. So that was the polling, and now we will walk you through the log-based CDC.
All right, so it looks like polling is not the perfect way to go. Don't worry, guys, we've got you covered. We have another approach, the log-based CDC. Let's start with the first thing. What are the logs? We are talking about transaction logs, which every modern database utilizes. The transaction logs is a log of all the changes that happen in the database. In case you want backup, in case you need to roll back transactions, every database has it, even though they sometimes name it differently, not transaction logs, but some bin logs. It's all basically the same. Yeah, so you have comprehensive history written in these logs. Every database has them. That's a great thing. So all we need to do is just check the logs. Check the logs, get the changes from them. Perfect. There is no chance that any change is missed. Nothing seeps through the cracks. If we have a mission critical reliability, we need all the changes. There is zero. We cannot miss anything. This is the correct approach. And also it's a lot more efficient or scalable against the poll-based approach. So, of course, nothing is ever as green as we would like it. So the first challenge we have, log volume limitations. If you want to track the transaction records, you need to store them somewhere. And often, if you have big databases, the transaction records or the transaction logs are big. You need a huge storage. Okay, we can fix that, no problem. We'll just delete the old ones and renew them. And then we get to the second problem, circular transaction log. If you are not fast enough, if you don't capture the changes as fast as they happen in the database, sooner or later, you'll lose the logs that get deleted. You have to work with this. You have to set the retention time to be optimal. You have to make sure that you capture the logs in time. Do you have, guys, any idea what to do when this happens, when we miss some log? Go. Oh, you speak on. Yeah, it is too late, but there are we can somehow handle this, not optimally, but there are some ways we have to do. Sometimes this can happen. Let's talk, if anyone wants to know what we should do or what we do, even though it's, as I said, not optimal, we can talk after the presentation. And now that we talked about the theory of CDC, let's move on to the Debezium, the tool that actually helps us to do the CDC. Debezium is an open source platform used for change data capture. It is open source, has a huge community of over 539 contributors. So those are people who create the code, not just the users. They write the code. So that's a huge community. It has a Red Hat backing. Most of the maintainers are paid by Red Hat. And it has enterprise, and it even gets, if you want, you can have enterprise support for it by Red Hat. And the most nice thing that we have is flexibility. Any industry standard database, you name it, Debezium supports it. Read data from MySQL, from MongoDB, SQL Server, Oracle, we can do it all, no problem. And okay, so that's the Debezium project. We can separate the Debezium project into 4 pillars or 4 components. First is the Debezium engine, which is a code that runs the changes. You can embed the code in your own Java application and just point it at the source, and the events will be in your code. You will have to handle them yourself. The second, and that's the oldest and most trusted part or component, is Debezium running in Kafka Connect. Does anyone know Apache Kafka? All right, nice. So Apache Kafka provides Kafka Connect for better integration. Debezium runs inside the Kafka Connect and sends the changes straight to Kafka. Then we have Debezium server and Debezium operator, the new stuff, and we'll talk about that later. And Ondrej, now let's dive into the inner workings of Debezium. Go on.
Okay, so you guys know Apache Kafka. That's great because, as Jiri said, the original Debezium connectors are all written as connectors for the Kafka Connect, which till now seems like a great idea. Debezium was created like 12 years ago or something like that, or 8, I don't know. It's quite a long time. And at that point, Kafka was the event streaming that you would go for. Now you have much more things. You have PubSub, you have Kinesis, you have, even if you want, you have these message brokers that are currently fast enough, like Rabbit, Rocket, and you name it. There are multiple differences. Now it's a little problematic, and there is also another thing that is problem with Kafka Connect from architecture that we were fighting for years now. If you look on this very simplified image of the architecture, you can see that there is Mongo connector inside the Kafka Connect. There is some internal Kafka sync. And the biggest problem is that this Mongo connector is just single thread thing. And you cannot parallelize anything inside the connect. You cannot spin up anything else. You have just single thread, and that is everything you are going to get. So this might get problematic, and this has some serious performance downgrades. And if we talk about the Debezium should be fast and you need your CDC to work as fast as possible, so not lose on any logs and so on, this might get the problem. So, as I said, but Debezium server is relatively new thing where we rethought all the architecture steps. This is just very simple image, but essentially the architecture of the Debezium was separated into 3 different areas. The first is the source, which is effectively the whole connector that was these old Debezium connectors run on Kafka Connect. This is it. But this does only the capturing of the events, nothing more. Then there is a second group, which is really important one, when you do the processing of the events. We still have to think about that if you capture these events, these are usually just string literals, or if you want to be more technical, it's byte array, but you need to transfer that to the string literals, and then you have to parse it to get some readable format. Then you have some transformations that user can provide that they want to get rid of this column, and essentially you are still doing operations under the relatively big string literals. And then of course you have to serialize it back to something that can be sent to the event stream. This is very expensive. These are very expensive operations that you can parallelize relatively easily, even if you have to order them later. If you have really big data, this should help you potentially. We don't have any performance test, to be absolutely honest, but we think that will help you. And the most important thing, the sync thread is no longer Kafka vendor locked. You can supply whatever producer you want. Actually, you can even write your own code doing like 5 lines or whatever. That's the main difference between the Kafka Connect and the Debezium server. And now back to Jiri.
Let's wrap this up. Thank you, Ondrej. Debezium server. The new version of Debezium, it's a standalone application and no longer runs inside the Kafka Connect, so you don't need the Apache Kafka stack. You don't need your own code. You just take it out of the box or point it at the source, point it at the target. It runs. We have the performance focus on our performance-focused architecture. We try to parallelize the transformations, which should gain us the speed increase we were looking for. We'll get back to you next year after some performance tests, or maybe not if they came back, if they came out wrong. Yeah, and then the last thing that's really important, you can send the data anywhere you want. It's a lot of things are integrated out of the box, and it's not that hard to write your own connection to the target system. All right, we are at the SREdays. I guess everyone at least touched on Kubernetes, and we will be no exception. We wanted us to get on the same page about Kubernetes. We were like, that's not easy. That's an easy task. Let's ask ChatGPT. Why not? When our intellect fails, ChatGPT comes to rescue. So we asked some basic prompt, give us the overview of Kubernetes if like we are junior programmers. Gave us 3 sentences. The first one is all right. The second 2 are a little imprecise. You don't need to read them. Just the first one, open source platform that automates deployment, scaling, and management of containerized applications. All right. We brought up Kubernetes. We talked about Debezium. Now let's go deploy Debezium on Kubernetes. Oftentimes, deploying on Kubernetes, something is not that easy as it sounds, but we got you covered. We have the 4th component of the Debezium project, and that is the Debezium operator. So the Debezium operator, classic Kubernetes operator, you've heard about them, automates Debezium server deployment, lets you easily set up and manage all the Debezium server instances, declarative way for setting up configuration and resources as it's standard, as we see here. Everybody does that. And it handles all the updates and health checks. There is some roadmap that what it could do potentially in the future, but right now, this is it. All right, now let's cut the talk. Let's move on to some practical showcasing. Ondrej, what have you got in store for us?
Okay, so I have really simple demo and I wasn't brave enough to do a live demo because of the Kubernetes cluster. So I have recorded it, but essentially the demo is pretty straightforward. We have some simple PostgreSQL database. We have Redis, which is the new thing, yeah. And we have Debezium server deployed by Debezium operator. I hope it will be visible. It seems quite all right. As I said, there is some OpenShift cluster in the background. You don't need to worry about that. And as I said, there is a Redis deployed, just a single pod, nothing fancy here. There is also the PostgreSQL, nothing fancy, really simple deployment that you can find on README Redis, Kubernetes or container or whatever they have. There's also a third application that we have there for start, this named database manipulation tool. That's something that we have been developing as open source project for about a year. Basically allows exports on the HTTP API, which you can manipulate databases and Redis through, so you don't have to port forward everything and this kind of stuff. So it's really nice. You can check it out later. But now let's look. Everything seems... Just check everything is completely clean. Redis, there are no streams, as you can see. It's really fresh deployment. So, okay, now we can deploy the Debezium operator. We have a couple of ways how to deploy the operator. We are supporting OLM, YAML bundlers, Helm. Helm is probably the easiest currently, or at least it's less work for the talks. Yeah. So there is nothing fancy. We have our charts. Then we just put the install on Helm and everything goes smoothly. The operator is written in Quarkus, so it's quite alright with speed. It's not Golang, but it's better than nothing. So yeah, once the operator is deployed, then we can take a look on how actually our server configuration looks like. You can see that this is very simple. I don't have any transformations, anything special on the database, anything special on the sync side. I have just address for the Redis. That's it. I have disabled all the authentication, all the stuff that should be enabled in production. So please don't use that example in production. And just wanted to show you guys that this operator can also take the Kubernetes secrets and expose them for like authentication to the database and this kind of stuff, which is pretty nice. Some operators don't actually do that, and it's quite risky. And there are some configuration, but these are basically just the default. Yeah, and then the only thing what we have to do is just to apply the YAML, and we can check if you can see that the Debezium server is running, or the operator has registered the CR. Now it will try to deploy the server. It's already deployed, and see it's doing something, some magic is happening, but it has nothing to stream because all the database is fresh, it's clean. Then we can add some things. You can see that we will add really simple, just two column table, some device ID, some temperature. It doesn't really matter what data you put in because we can stream all the data types, even the big ones, the blobs and this kind of rerouting stuff. And we will just put that to the database through the DMT because I didn't want to open the PSQL. And now we can check the Redis. because Redis streams, I don't know if you are familiar with that, guys, because it's quite a new feature in Redis. But essentially, you will get something like this, which is like intensely big description of the database schema and the actual data in the database. You can always strip everything there, or you can just reroute the schemas to the schema registry or something like that. This is the default, so you can add things. You can actually customize what Debezium will send you in every aspect. But you can see that there was a change. There's device ID 1, current temperature, blah, blah. You can, somewhere there is the operation that happened. Yeah, and this will basically go on, and it might stop if that fails or breaks, but usually it don't. So yeah, and that's it. I don't have any other things in the demo because I really didn't know what audience will be there and how much time we will have for the demo. So yeah, that's it. Yeah, there are the sources for the demo if you want to take a look. This will take you to the GitHub, not to some sketchy page, so it's all right. I have even written a README just like a half hour ago, so yeah, and that's it. Sorry. So, do you guys have any questions?
Thank you guys for your presentation. I have a question on the Debezium server and how you run multiple threads. When the order is important, do you expect the consumers to do the ordering, or would you guarantee ordering when you push it to the sink?
Okay, so currently we are ordering all the events. So you will get everything ordered. We have to guarantee you eventual consistency, but that's not eventual. We are strongly consistent. So currently we order everything, but we were thinking about supporting unordered delivery. If you want to use these events maybe for some later analytics or something like that, you don't really care if you will do the ordering somewhere in the future. Yeah, currently everything is ordered. You don't have to worry about that.
Thank you.
Nice talk. You showed us you capturing data from Debezium, but how do I use it? What can I get as an output? Do you have a screenshot of that?
That was what I showed in the demo. Let me get back.
Oh, I thought it was an input.
No, this is the event, this is the Kafka event format because we are still little bound to Kafka internally. So this format is essentially Kafka event, and this is it. You will essentially get one part which will describe the schema of the database that you are capturing, and then you will get the payload, which are essentially these before, after fields, actions, and this kind of stuff. If that answers the question.
I don't know what to do with this data. I'm sorry.
We had a quite nice demo on the last conference, but that demo was for 20 minutes, so it was not possible to do it here. But for example, I had this little app that was querying the coin cap market all over again, and we were just changing the values in the database, and you don't have any information about the timestamp there. And if you just put Debezium in work, you can essentially, for example, just an example, you can essentially create a whole histogram of changes of that market. That's just an example. Our biggest customers are, for example, companies that are selling tickets for concerts or anything like that, where you have big or relatively high amount of changes on the database, and you need to do some analytics afterwards on those events that happened. Yes, might be.
I've got like the opposite questions. I'm sure you've seen a lot of deployments. Like, where shouldn't you be using Debezium? I imagine there's lots of cases where it doesn't make sense.
That's the tough question, because there is nothing else than Debezium if you want to do the change data capture. So if you have really small thing that you want to do, like prototype project or something like that, you should use just Debezium engine and run something embedded into your code, which can have much smaller memory and hardware footprint than Debezium. But otherwise, if you want to do change data capture and you want to do it properly, you have to think about it that will be cost effective for you, because, like, honestly, maybe, for example, Golang have embedded CDC for Postgres, I think, when you can just simply use the driver to do the CDC. But I don't know about any other language to do it. And to be honest, Debezium is free. And for example, if you have Oracle, you would have to pay for the Golden Gate license, which is essentially more expensive than the Oracle Rec license. So not sure about the situation where this is not optimal.
Okay, thanks. Oh, because it should be the last question.
Thank you, first of all. I have a question about, can it be like fine-grained subscription on what exactly I'm interested in from that data source, like a specific table, specific columns?
Yes, you can filter everything.
And I imagine that it can be in a scenario of real-time apps, like it can replace Firebase, for example. Is it possible? What I mean is that, for example, in Firebase, you are also subscribing to data source, but it's already like you don't have any control on the data source itself. And also you have to pay. So if this one, I can control the database as a source, and also I can control the subscription on what exactly I'm interested in, the changes. So I think it might fit in such a scenario.
In that case, yes, but you should talk with us about what is going to be the failover if you miss the transaction log, because that might be a little bit problematic for you. Or there is, I think, a solution that it could work, but you would have to think a little bit about the configuration for Debezium. Okay, so we have run out of time, so thank you very much, guys.